Okay, so every semester in nursing school, I have to do med math. So this is a video for me to help remember how exactly to do it, and if this can help other people too, that's great. So with med math, I need to remember dimensional analysis, okay? That's where we are crossing out certain units in order to end with a unit that we want. So to do this, the first step that I think is the best approach is to remember the ratios. So with the ratios, the only ones that I have learned are the following. This is how I normally set everything up. I start with 5, 15, 30. So we got 5 milliliters, 15 milliliters, and then 30 milliliters. Okay, I do 5, 15, 30, and I know that this is going to be 1 teaspoon, 1 tablespoon, and 1 ounce. You just got to remember these ratios, okay? So after I do that, I normally just somehow complete the rest just from my own memory. So then we have 2.2 pounds, which equals 1 kilogram, and vice versa. And then we go to big numbers. So 1 gram equals 1,000 milligrams. Same thing for the liters. 1 liter equals 1,000 milliliter, and 1 milligram equals 1,000 microgram. And then we have this random one. 1 cc equals 1 milliliter, and then 1 kilogram is equivalent to 1,000 grams. Here's another one, 8 ounces, like a cup of coffee. One cup of coffee is 8 ounces. I think that's everything that I've had to remember in the past. And then with this, just keep in mind that, so if we're saying like, okay, so 2 tablespoons, right? 2 tablespoons is equivalent to how many milliliters? Well, 1, 2, just times that by 2, then we have 30 milliliters. Okay? And then some other rules I need to remember is round. So most of the time, we're rounding to the 10th place. So that's like this. So if this number is above 5, this number will increase. If it's below 5, it will stay the same. So let's say 0.32. Rounding to there's 10th place. So that's a 2, so that's going to stay. It's going to be 0.3. If we're saying 0.36 is larger than 5, it's going to be 0.4 instead. Most of the time we are rounding to the nearest 10th place, but there are exceptions. So tablets can normally be scored, right? Because they normally have a line in the middle. So the answers for tablets will always be either to the nearest 0.5 or to the nearest whole number. Okay, and then capsules, you can't break a capsule into a half because the contents in it are liquid. So a capsule, you will always round to the nearest whole number. And then same thing for drops per minute, you're also always doing it to the nearest whole number. And that's all that I can think of as of now. Okay, so let's do a practice problem. Okay, so if we have order for 0.5 milligrams of a medicine, doesn't matter how many times a day, and let's just say that what we have on hand available is 125 micrograms per tablet. So I'm going to write tablet underneath because that's a ratio. For every 1 tablet, it's going to be 125 micrograms. So the question's asking for how many tablets will the nurse give. So I'm going to write tablets here because I know at the end I should only have tablets. So since I know on end of tablets, I'm going to start with tablets. And I know that the ratio that's given right here gives me 1 tablet for every 125 micrograms. So 1 tablet, I'm going to circle this so I know that this is the end product that I want. 125 micrograms. Okay, now we need this to cross out. So we have micrograms here and we don't have anything else, but we have a milligrams. So if we go back to the chart, I know that 1,000 micrograms makes 1 milligram. So this ratio right here, this actually has nothing to do with this is simply to find a way to cross cancel. So we're not like actually thinking about it too much. We're just really looking into the units. So because we have a microgram and a microgram at the top and bottom, I can then cancel this out. And so we're doing, so I'm right down here, 1,000 over 125. Oops, let me go a step further because microgram is still, or milligram is still here. We need that to cancel out because we don't need milligrams. So because we need that to cancel out, this is where this one comes in, 0.5 milligrams. So now I can cross cancel these two. I'm just gonna put that over 1. So cross that out. This is the equation that we're looking for. So 1,000 times 0.5 over 125. Okay, and then when we do the math, which I'm doing on my calculator, so 1,000 times 0.5 is 500. So 500 divided by 125 equals 4. So the answer is going to be 4 tablets because we know that a tablet can either be a whole number or it can be a half number. So we're totally fine here. Okay, so now moving on to the next question. So if we have an order of a medicine that is 1 order equals 1.8 grams, doesn't matter how many times a day for this question, for any of the questions really. What we have, what is supplied, what we have available is 600 milligrams per tablet. Okay, I'm just going to go ahead and put 1 tablet. This is just for my sake. So the question's asking how many tablets of this medication will the nurse give? So since I know I want tablets at the end, I'm going to start with tablets. So 1 cap, and I have the ratio right here, right? So 1 cap equals 600 milligrams. Okay, so now I want to cancel out the milligram. So what can I do to cancel the milligram? Well, I know that 1,000 milligrams is the same thing as it's the ratio for 1 gram. So I have milligram here and a milligram here. So I know that I can cancel these out. But I still have gram here. I don't want to be left with gram. And plus, we still have this number here. So it says 1.8 gram. I'll write that here because I know that I can cross cancel these two. So here's a gram and I'm going to cancel that. And so now we'll divide across. So we have 1,000 times 1.8. Okay. And then we're going to divide that by 600, which equals 3. So we know that this is the correct answer. Okay, here's a different type of question. So the order is for 75 milligrams. And the label has, or the available thing that we have, or what is supplied, 25 milligrams divided by 5 milliliters. Sorry, not divided by, but the label reads 25 milligrams for every 5 milliliters. So if the question's asking for teaspoons, don't freak out. We just want to know how many teaspoons that we're supposed to give the patient. Okay, so if you want teaspoons, let's start with teaspoons. So clearly there's nothing here that reads teaspoon, but going back to the ratios I had to remember, I know that I could cross cancel the 5 milliliters because we know that 5 milliliters equals 1 teaspoon. So I'm going to start with 5 milliliters, and the ratio for that is 25 milligrams. Okay, so this is what I'm working with here. I want this number, whatever comes here, to cancel out the milliliters. So I know that 1 teaspoon is the same thing as 5 milliliters. Perfect. So now I can see that I can cancel milliliters and milliliters. Cancel out, and this is what I want ultimately. But the problem cannot end yet because I have milligrams right here. I need to cancel that out. And we have milligrams right here. The only thing we haven't used. So I'll continue the problem. So 75 milligrams. Perfect. It's important that this is on the numerator because if it was on the denominator, we wouldn't be able to cross cancel that. So we have milligrams here and then milligrams right here. So I can cross that out. I can cross that out. And then we can write it all out. So we have 5 times 75 divided by 25 multiplied by. Okay. And the only unit left is teaspoon. So 5 times 75 equals divided by 25 times 5. 3 teaspoons is the answer. Okay. The physician orders 0.125 milligrams of something. Doesn't matter. We're not focused on that. Okay, and the label reads what we have available, what we have supplied, what we have on hand is 125 micrograms per tablet. So I'm going to write per tab. Okay, so I know I want to end with a tablet because asking how many tablets will I give. So I see that this is right here and I want to end with that. So let me write that down. One tablet. The ratio for that is right above it. So per one tablet is 125 micrograms. Okay, I have micrograms right here. I'm good with this. I'm going to keep tablet. So I really want to cross out micrograms. Okay, going back to the ratios I remember before, I know that 1000 micrograms is the ratio for 1 milligram. So I can cancel out microgram and microgram, but I'm still left with milligram. And we just so happen to still have what was ordered. So let's cross cancel this. 0.125 over 1 milligram. So it looks like we have a milligram here. I can cross cancel both, and I'm only left with tablet. So when I write that out, 1000 times 0.125 divided by 125, that gives us 1 tablet. Okay, this one is a very short one, but always tends to freak me out a little bit because I'm in the dimensional analysis zone. So the question states, how many hours will it take for 600 milliliters to infuse at 80 milliliters per hour? So we have 600 milliliters to infuse at 80 milliliters per 1 hour. So we want the hours to be the answer. So I'm going to write hour. So this is what we wanted. So 1 hour here. This is our ratio, 8 milliliters. If you want to cross cancel milliliters, so we can put that right here, 600. Okay, perfect. That crosses out. We have 600 divided by, oops, this is supposed to be 80. Okay, and the answer is 7.5 hours. Simple division question. Okay, moving forward, I'm just going to have the information on the screen, but whenever I'm writing these questions down, I'm always writing what the doctor ordered or the desired medication, and then I'm always writing down what we have or what is available or what is supplied also. And then I'm always starting the equation with what I know the answer will have. And from there, I want to try to ensure that the unit that I want is never cross-canceled. Okay, so this next one, we have ordered 150. So we want 150 milliliters for 1 hour, but we only have 60 drops per 1 milliliters. Okay, the answer that we want specifically from the question says how many drops per minute should be given. So I know that I'm going to be writing that down first. So I want to make sure that keep the units in mind when doing this. So G2T, that means drops. So I have G2T right here. I'm going to make sure that I have G2T as the first number that I put down, first part of the equation. So I'm literally just transferring this right here. Okay, the bottom is milliliters. I have something that can directly cross out milliliters, which is what is given to me right here. So this 150 milliliters over 1 hour will go in the next one. So I already know that I can cross cancel this out. So cross that out. I'm looking for minute. I'm left with hour. So I need to cross that out. The ratios from earlier, this was not in here, but this is something that's obviously I should know. So in 1 hour, we have 60 minutes. So I have 1 hour equals 60 minutes, and I can cross out hours, and I'm left with minutes. So right here, per minute. I'm going to write everything down here, and I end with 150 drops per minute. Okay, this next one can be a little tricky. The question states, the order is for 250 milliliters D5W with potassium chloride 15 MEQ over 2.5 hours. So I'm just going to write down what I have so far. So the order is 250 milliliters of something. And this with potassium chloride 15, we don't really care about that, but I mean, we can keep it in mind if we want, over 2.5 hours. So I know the volume is going to be given over 2.5 hours. That's what we really care about. We don't really care about this. The tubing drop factor, so what we have, so I'm going to write H for have. The tubing drop factor is 60 drops per 1 milliliter. The question is asking how many drops per minute will be given. Okay, this is what we're looking at. So I can already recognize that we have drops right here. We have minutes right here. So I'm going to do 60 drops over 1 milliliter. And the only reason why I do 1 milliliter is because this is the ratio that's already given. So I'm literally just transferring this there. So already I have the numerator of drops. This is good. Just like the other question. I now am concerned about this. I want to get rid of that. And the order is in milliliters. So I can cross-cancel the milliliters by putting the order in. So I have 250 milliliters. Boom, I can cross-cancel that out. Let me finish writing down the question. 2.5 hours. So I can cross that out. I can cross out. We're looking for minutes. This is hours. So we need to keep going. So I know that 1 hour is the same thing as saying 60 minutes. And if I do that, I can now cross the hours out, and I'm left with minutes. Drops per minute. Okay, so now I write all of this down here. Simply multiply across, and I'm left with 60 drops per minute. Oh, not 60. 100 drops per minute. And this is a reminder, if on these drops questions, the result is, let's just say 27.8. 27.77, this is a different side note. So let's say the answer was this, for how many drops per minute would be given. Remember, drops per minute, you cannot, or you have to do it in a whole number. So it cannot be like this. You need a whole number. So this question, or for a different question, but pertaining to this. So we're looking right here. We don't care about this number. We do care about this number because this determines if it stays 27 or it goes to 28. So this is 5 and above. So we know that this particular problem would be drops per minute. That's just a side note. Other side notes about leading zeros. You always need a leading zero if your answer is below less than 1. This is what I'm referring to, leading zero. If I have 2.75, for example, it literally doesn't pertain to this because we have a leading 2, so it doesn't matter anyways. So for example, 0.750, would we need a leading zero on this? Yes, because this is a less than 1, so the correct answer would really be like this, 0.75. You never have a trailing zero either. Don't ever put trailing zeros. Okay, so for this next question, I'm just going to read it out. Your patient returns from the PACU with the following order. Morphine, 3 milligrams per 2 hours, as needed. The vial reads 4 milligrams per milliliter. The question asks, how many milliliters should the patient receive? So here are the vials. If the doctor wants 1, 2, 3 milligrams of morphine, but we have 1, 2 of morphine, so this is what we have, this is what the doctor wants. So if this is in the same vial, wouldn't we want to give 3/4 of the vial? The answer is yes, 3/4 milliliters or 0.75 milliliters of that whole. When reading the questions, it's important to recognize what the question is actually asking, because my initial reaction was to write out a dimensional analysis, which included the hours portion. But I realized it didn't make any sense to do it that way because the question is not asking for time, it's asking for the volume. Okay, here's another one that may be confusing when initially reading it. The question asks, the order is for ascorbic acid, 300 milligrams and 200 milliliters. So we have the dosage and then we have the volume. So 300 milligrams and 200 milliliters of normal saline to be infused over 6 hours. How many milliliters per hour? So I know this is the answer that I should have, the units in. How many milliliters per hour should the IV infusion pump be programmed for? So with this problem, I already know that I have milliliters right here, and I have hours right here. This literally doesn't matter in our problem because it's not asking us anything about that. It's literally asking us milliliters over hours. The 300 milligram doesn't matter. The answer doesn't revolve around that. So this is an extremely simple 200 milliliter. We already have the end product here over 6 hours. Again, already have the same. And simple division problem. The answer we get is 3.23, I believe. And so we know that when we're doing this, we always round to the tenths when it comes to infusion. So 33.3 because this is... Okay, so here's another question with units. So we're given the order is for 4,000 units subcutaneous. What's available, what's supply that we have is heparin 5,000 units per milliliter. How many milliliters should the nurse administer? I know the answer needs to be milliliter. I'm going to write that down first. And I recognize that we have milliliters right here. So I'm going to put down the ratio of 1 milliliter over 5,000 units. I'm just going to do U just to shorten it out. And I want to cross cancel. So I will write down what is ordered right here. Again, just putting units to shorten the answer. So this cross cancels, this cross cancels. What I'm left with is 4,000 over 5,000 milliliters. And that ends up being 0.8 milliliters. Okay, here's the setup for the next one. Order is heparin 25,000 units in 1,000 milliliters of 0.9 normal saline to infuse at a rate of 1,000 units per hour. How many milliliters per hour will be set on the infusion pump? So I already know this will be the first thing that I write down. I'm looking for something that will let me keep milliliters and hours. So if I look at my problem, I recognize that we have milliliters right here. So I write down milliliters and the ratio is right here, which is 25,000 units. So I want to cross cancel units because units is not what we're looking for. So I have units right here, the infusion rate, units right here. So I know that I can cross these two out and just write down the ratio for this. And this just so happens to be what we want. So I rewrite everything and I get 40 milliliters per hour. This next problem says 100 milliliters normal saline IV to be infused over 30 minutes. Available is 100 milliliter bag of normal saline and IV tubing with a drip factor of 10 drops per milliliter. Calculate the number of drops per minute. This is the first thing I'm writing down. Always. I'm going to try to find something that matches that. So I have 10 drops, writing down the ratio for 1 milliliter. I want to cross cancel milliliters. So I'm going to grab this ratio, insert it in milliliters, cross cancel. 30 minutes, then drops. I have what I need. So it's just a matter of multiplying everything. And what I am left with is 33.3 drops per minute, but I know that drops can only be whole numbers. So I'm going to make sure that I round. 33 drops per minute. Infusion rates are to the nearest tenths, but when you're calculating drops per minute, you always want to make sure that it's a whole number. Okay, here's the next question. 750 milligrams equals how many grams? Well, I'm going to start with my answer, grams. I know that 1 gram is the same thing as saying 1,000 milligrams. Okay, and I want to cross cancel milligrams, so that's what I'll do. I'll put 750 right here. These cross cancel. I end with 750 over 1,000, which equals 0.75, but remember, we are rounding to the nearest tenths, so I am looking at this number here. So 5 or greater, I'm going to increase the number to my left. So the answer is 0.8 grams. Okay, here's another one. 50 pounds equals how many kilograms? I'm going to start with the answer kilograms. I know from the ratios I remember previously that 1 kilogram equals 2.2 pounds. Now I'm trying to find something to cancel out the pounds. So I have pounds here. Those will cross cancel, and I will end up with 50 over 2.2, which equals 22.72. But I know that I need to round to the nearest tens place. So 2 is below 5, so my answer is going to be 22.7 kilograms. The question reads, the order is for 500 milligram every morning. We have 1 gram per tablet you will give. So I know that we're talking about tablets here, so I'm going to write down tablets first. So I want to keep my tablets. I'm going to write down this ratio of what we have. So 1 tablet over 1 gram. I want grams to cancel out, right? So going back to what the ratios were that we remembered. These are so important to actually sit down and just rewrite them because they come up all the time. So 1 gram over 1,000 milligrams. I'm using this in order to cancel out the grams. 1 gram is equivalent to 1,000 milligrams. I'm using the milligrams because this is what we have ordered here. And I needed to cross cancel. So boom. Now we're left with 500 over 1,000, and that equals 0.5 tablets. And we can leave it like this, because remember, tablets are either answered in halves or wholes. The question says, the order reads amoxicillin, 650 milligrams IV now. Available is amoxicillin 1 gram in a powder form. The reconstitution instructions say to dilute the medication with 10 milliliters, sterile water to make the concentration 100 milligrams per 1 milliliter solution. So a lot's going on here. But if we really break it down, what the question is giving is that we have 650 milligrams. We want 650 milligrams of something. And the instructions are saying that we already are doing this. We're putting 10 milliliters to make this. So this is what we have right here. So it ends with saying you will give what? So if we don't know what we're starting with, well, we're talking about medicine. So how much of the medicine will we give? So milliliters. We're talking about milliliters. We're not talking about milligrams or grams. We're talking about the volume. So we're going to start with milliliters. So 1 milliliter, this is what we want to end with. We're doing the simple ratio of what it is. And we want to cross cancel milligrams with what we want. So right here, we're cross canceling that. We're going to get 650 over 100, which equals 6.5 milliliters. The order reads 10 milligrams furosemide. Available is furosemide 40 milligrams per milliliter. What we have, and then what we want. Okay, so it says you will give what? Okay, so I know I'm going to give it milliliters. So I'll start with milliliters. I'm simply just going to write ratio right here. And I have milligrams down here that I want to cross cancel. So I'll bring what we have ordered down here to cross cancel. This is what we end with here. When we divide it, we get 0.25. But remember, we're rounding to the nearest tenths. So we have a 5, which means the answer is 0.3 milliliters. Drug, 300 milligrams daily. What we have is 250 milligrams per milliliter. Okay, so what we want, and then what we have. How much of the medication will the nurse prepare to administer? I know I want to end with milliliters, so I'm going to write milliliters first. This ratio right here is what I'm going to write down right here. I want to cross-cancel milligrams with milligrams. Boom, we end with 300 divided by 250, which then equals 1.2 milliliters. The next question reads, the order is for 100 milligrams, and the label reads 125 per 5 ml. You will give. So I know I want to end up with milliliters, so I'm going to put milliliters first. Same thing as before. I'm just putting this ratio. And down here. Okay, and so I have milliliters over milligrams. I want to cancel out the milligrams, so that's when I bring this bad boy in, and I cancel milligrams. This is the equation I end up doing, and it ends up being 4 milliliters. Physician order 7.5 milligrams. We have 5 milligrams per tablet. What we give, this is what we have, this is what we have. This is what the order's for. You want it in tablet, so I'm going to write down ratio first, and I have one tab. Perfect. I want to cancel this out. That's why I brought the 7.5 milligrams here. Now I can cancel this and move on to dividing it. Right there. End up with 1.5 tablets. Exactly what I want. Next question. We have 1,000 milliliters of nasal saline over 8 hours. Okay. You will set the pump rate at what? This is simple division question. 1,000 divided by 8 hours. 125 milliliters per hour. Next question. Infuse 500 milliliters over 4 hours. The drop factor is 20 drops per 1 milliliter. So the question is giving us the drop factor. So if you can imagine this, right? So we have the medication drip, drip, drip. So do you think, if you can imagine this in the hospital setting, does it normally happen like per minutes or per hours? So when it's dripping, or like the flow rate or the drip rate, that's going to be per minute, every minute. Because we're talking about the manual infusions here. So infusion rate or drop rate, we're talking about GT over minutes, so manual infusions. But if we have an electric pump, or if it asks like what the pump rate is, then typically we're setting those per hour. But this question is specifically asking it's just saying what will the infusion be set to. So infusion rate, we're talking about drops per minute. With that in mind, let's start with drops per minute. Okay, I have 20 drops right here. I'll write that down with the ratio that it's giving me. And so now I have drops. I do not want milliliters though. So how do I cross cancel that out? 500 milliliters over 4 hours. This can successfully cancel out, but we don't want hours, we want minutes. So we're going to continue. 1 hour, 60 minutes. You can successfully cancel out hours, and hours, we're left with minutes. We're left with drops per minute. So when you write everything down, it's 20 times 500 over 4 times 60. Okay, that ends up being 41.6, but we know that when we're talking about drops per minute, it's always going to be a whole number. In this question, you need to look at the tens place. It's above 5, so the answer is going to be 42 drops per minute. Okay, that was a really long practice time. So that's a wrap for the second semester med math. For next semester, it's a great idea to come back here, do on 2 times the speed, just to remember everything and how I write things down. And if you are not me, and you are watching this, congratulations, that was very long, and I hope you learned something.